Welcome to The Explainer. Today, we're rolling up our sleeves and diving into some truly transformational source material to tackle one of manufacturing's absolute biggest headaches. We're going to look directly at the core concepts and data that literally change the way factories operate worldwide, turning sluggish, inventory-heavy floors into sleek, highly responsive systems.
Think about your own shop floor for a second. Think about the immense waste caused when machines just sit there idle, completely destroying your continuous flow. You've got operators waiting around, parts piling up, and production timelines stretching way out into the horizon. It's a complete flow killer, isn't it? The source material we're unpacking today forces us to confront this question head-on. Exactly how much of your operational life is being drained away simply transitioning from making product A to making product B?
Well, before we can fix a problem, we've got to clearly define it. The Lean lexicon provides our exact baseline here. A changeover is not just the time it takes to unbolt a tool and bolt a new one in. It's the total elapsed time between the absolutely last good piece of the previous run and the very first good piece of the new run. That means all the tiny adjustments, the test runs, the tinkering, the defects, that all counts as changeover time. And that is the ultimate enemy of efficiency.
So here's our roadmap for getting those changeovers down to single digits based on the foundational research. We'll cover the setup time problem, enter SMED, internal versus external operations, the 6 steps to reduction, and finally, eliminating big losses. Let's get right into it.
Section 1. The setup time problem.
According to the Total Productive Maintenance Frameworks, setup and adjustment times represent one of the notorious 6 big losses that just drag down equipment effectiveness. Here's what actually happens when you have long setups. Your output gyrates wildly from hour to hour. Because changeovers are so incredibly painful and time-consuming, plant managers are basically forced to run massive batches of a single product just to justify all that downtime. And the result? Small and sometimes huge piles of inventory accumulate between every single operation. When that happens, the researchers note that the benefits of a continuous cellular layout are totally wiped out. You aren't flowing anymore. You're just batching and waiting.
Section 2. Enter SMED. SMED stands for Single Minute Exchange of Die. And the crucial point here is the target, reducing changeovers to a single digit, meaning under 10 minutes. Now, when you first hear that, it sounds completely impossible, right? If your current changeover takes 4 hours, getting it under 10 minutes sounds like pure magic. But as the source material proves, it's definitely not magic. It's a highly systematic methodology.
We have Shigeo Shingo to thank for this system. He was an absolutely brilliant engineer who taught industrial engineering methods at Toyota from roughly 1955 all the way to 1980. Shingo's genius was combating the massive wastes of mass production by actually making small lot inventories feasible. Think about it. If you can change over a machine in 5 minutes instead of 5 hours, you don't need to run a batch of 10,000 parts. You can run a batch of 50, exactly when the customer needs them. And Shingo wasn't just dealing in theory either. His methods led to an astounding 98% average setup time reduction in the facilities he transformed. 98%? Insane.
Section 3. Internal versus external operations.
This right here is the real aha moment from his research. Shingo realized that we were looking at setups all wrong. We were treating every single action as something that had to happen while the machine was totally shut down. He blew that up by separating setup operations into 2 distinct categories, internal and external. Internal setup operations are those tasks that can only be done when the equipment is completely stopped. For example, physically removing the old die from the press and inserting the new one. External setup operations, on the other hand, are tasks that can be performed while the machine is still happily running and producing parts. Think about transporting the new die from the tool room to the machine side, or grabbing the right bolts and wrenches. You literally don't need to stop the machine to go look for a wrench.
Section 4. 6 steps to reduction.
Okay, so how do we actually pull this off? Here is the exact tactical 6-step sequence required to transform your manufacturing environment. Step 1, you've got to measure the total setup time in your current state. No guessing here. Get a stopwatch, film it, and document every single second. Step 2, go through that footage and identify the internal and external elements, calculating the individual times for each. Step 3, convert as many of those internal elements to external as you possibly can. Step 4, once you've moved everything you can to the external side, focus your engineering power on reducing the time for the remaining internal elements. Think quick-release clamps instead of traditional, slow bolts. Step 5, reduce the time for the external elements. Get your tool cards organized, streamline your transport. And Step 6,
Standardize the new procedure. Because if you don't lock the new standard in place, human nature guarantees you'll drift right back to the old 4-hour changeover.
I really want to emphasize step number 3 for a minute, because this is the magical catalyst of the whole thing. When you actually start observing setups on the floor, you will be shocked at how much time is wasted with the machine turned off while an operator is simply walking around looking for a tool or fetching a forklift or staging raw materials. All of that is just external work masquerading as internal work. By rigorously converting those tasks, meaning doing all the prep work before the machine ever stops, you immediately slash your setup time, often by half, before you even spend a single dollar on new equipment or fancy clamps. It's a total game changer.
Section 5. Eliminating big losses. The sources remind us of Taiji Ono's categorization of the 7 major wastes typically found in mass production. And mastering SMED is basically a direct assault on these wastes. Specifically, it wipes out the massive waste of overproduction and inventory. When setups take forever, you overproduce to compensate, right? Which creates inventory. And inventory hides defects, increases conveyance, and completely ties up your capital. By implementing the SMED system, you dismantle the very justification for overproduction in the first place.
And that brings us to the ultimate goal. The sources emphasize a Japanese term here, heishunka, which roughly means levelization. SMED makes small lot production not just possible, but actually economically feasible. By eliminating those massive setup bottlenecks, your products can finally flow smoothly and continuously, exactly when the customer needs them. You are no longer managing mountains of work in process, you're managing a sleek, responsive stream of value.
As we wrap up, I want to leave you with a really provocative quote mentioned in our source material from Dave Lagozzo, "Eyes for flow, eyes for waste." When you walk out onto your Gemba today, what do you actually see? Do you see the hidden wastes of massive changeovers? Take these tools back to your operations. Find those bottlenecks, separate your internal from your external tasks, and start your journey to the 10-minute setup today. Thank you for joining me for this explainer, and I hope this sparks an absolute revolution on your production floor.